This one. Meep. Yeah, that one. Okay. Thank you. I'm super excited to be here. And I'm super excited that I feel like already in several of the conversations, people have been like, but what about the data? Because that's a lot of what I'm going to be talking about. And I'm going to talk a lot about metadata, because this is actually all I talk about now. So you get to join me in that journey. This is a little bit about me. I work in many different places, DeSci Labs, SciOS, MetaGov, talking about a lot of different things. But for getting into what I'm talking about today, I'll set the stage just with a quick overview of some issues in research. This policy that I've thrown up on the slide is the Nelson memo, which a while ago said, hey guys, every publicly funded bit of research needs to have open data, needs to have open code, needs to have open publications, we need preprints, we need all these things. But as you see in this little portion down here, it says, despite the lack of details of how these policies will be introduced, it says that we should have open things. So there's this core limitation of policy can sometimes move faster than the technical infrastructure, where it says, hey, we need to do these things, but it's up to you to figure that out. So how are we doing on following that policy? The first thing I'll bring up here is you can see we're increasing in us saying that we have data available. Does it mean we have data available? Not really, but we're saying it more often, so that's good. As of 2023, about 20% of papers are saying they have data available. Next, we have this bit of information here, which says, all right, over 2 million publications, we have like 5 to 10% say that they have public available data. 1 to 3% actually had publicly available data. And was it actually usable, findable, discoverable in a way? I don't know. So we might say we have publicly available data, but there's a lot of additional issues that come up there. And then there's another issue that pops up, right? We have reference rot. So you say, hey, I have publicly available data, and then you give them the GitHub, and now the GitHub is gone. So this is link rot. The data just disappears because you're not maintaining it, your infrastructure no longer manages it. Or you have content drift, where you actually change the information in the link. And this might happen even with publications. The content might shift. And so, but we don't know that. And so when I cited that previous research, they might have had a retraction. They might have had any sort of things that changed that paper, but I don't know that. And so my paper still relies on it. And what we find is that even with DOIs, which are the academics identifier, they're meant to be the most persistent link on the internet to make sure we're not losing our research. More than half of them are actually unsuccessful when you're querying from an external network, meaning like not from your university and not from Crossref or any of these major institutional networks. And only about 33% of them, even from the most validated networks, when pinging to get your DOI, return nothing. Or not return nothing, they either return an error that says, hey, there's nothing, or they return an error that says, oh, the content changed, it's in a new location, I don't know where it's at. So we're losing a lot of our research. And then you see this last slide here, which is an indication, it looks like we're going up. Again, this is so percentage of links to data sets, so we're actually linking. But even as you see, it's only up to about 10%. And one thing that you'll notice is it's just links to data sets. It's not integrated into our platform. It's just a link out to a GitHub that might last or to your institutional repository. It's somewhere completely out. So there's two things. One, it's very expensive to manage this. Resource disparities mean that there's only certain people who can do this. And then the biggest conclusion from one of the big reports that came out in 2023 was we really need practical support. Like, we have a policy and people are trying to do things, but really they're just increasing, linking to things, and a lot of the information is being lost. So as a summary, we want data, but the first thing is we're not actually publishing it. Then we might not give it an identifier that actually lasts, or the identifier might have gotten lost in the process, something switched. If we can get it, it might be different. The information might be different than before. And if we solved all that, the information is everywhere. It's not centralized. We can't actually use it in a high quality way. So this is what DeSci Labs is trying to attack with the Codex protocol. So the Codex protocol, I'll start actually from the one below. The first thing, we want data, but we might not give it an identifier that actually lasts and actually permanent. For a lot of you who are into Web3, you can understand that if you're publishing on a blockchain, that's a pretty nice permanent thing. So we publish to the Interplanetary File System, IPFS. This is just peer-to-peer communication about file content. You can query it for a content identifier. We'll get into that in a second. Anybody can add to this information. And it's uncensorable, so it doesn't rely on DOI or Crossref or anyone to maintain this. It is maintained by the community network. So we have a persistent identifier. Now the identifier might have broken. It might not have the proper information. So this is where content identifiers come in. It gets a little bit into like, why is IPFS useful for tracking content? It's because it's not based off of location, which is great because if I switch my journal page, my access location to a new place, I can still always access that information. So the maintenance of maintaining my link drastically reduces from needing to change and update every time you have a reorg or a rebrand or anything like that. You drastically reduce the amount of maintenance because it's based off of the actual content. So that's really helpful. Again, anybody can use content identifiers. You don't need a certain protocol. It works even if the file moves into different places. You can always check, hey, is this actually the information that I published? Yes, because if I hash it again, it's the same thing. And it can't switch, because if you do switch it, now it's a new identifier. This actually creates a problem. So if we can't get it, it might be different than before. This is content drift, what I was talking about previously. But now we have this issue of like, we have a new identifier for this new version. But how do I know that this new version is related to the old version? How do I track that information? And also, how do I know that I'm interested in this random identifier? Now we need to associate a lot of metadata and information with it. So we need kind of this high-level understanding of versioning and navigation. So this is what DeSci Labs did, is they grabbed Ceramic. So Ceramic is a protocol, go check them out, they're super awesome, but they are a metadata layer for storage protocols. And so what we can now do is we have a single stream. The stream has a persistent identifier that lasts all the time, and it is a stream of every data commit that comes to that single stream. And so now we have content identifiers for every bit of information. We have basically a persistent DOI that actually persists and doesn't disappear over time for every single change that you've made to your research, and it's linked to a stream, so you're not losing the link all the time, which is exciting. Each new version is an addressable commit. Only the author can update the stream. This is something for Ceramic, and it doesn't actually directly interact with the blockchain. It's just a layer on top. So this can be faster. It can be a lot of those things. So as you can see, you shift from wandering content identifiers and information into a stream that links everything together. All right, now we've still got this problem where you're publishing your data on GitHub and you're publishing your code, or your code's on GitHub and your data's on Zenodo, and you're trying to throw all these different things in many different places. So how are we linking that together? And this is the final thing that Codex is doing, where it's really defining this graph of entities. So instead of just putting your publication up on DeSci Labs, you put your code, your data, and all your information, and you don't need to put it up there as its own thing. You can just throw in the link to your GitHub, and now it has a persistent link that will always link your publication with your data and all the other information that a machine can traverse. So it allows us to take the context, the really rich context of our publications, metadata, all this information, and link it to the actual data that we can do things with. So if you see, nodes are published content, edges are the relationships between those published content. You get many different node types. It also gives you very rich information, so user profiles, metadata additions. And if you see this, you can look at this kind of thing. It's like, now this chunk of information, right? You have the research object itself. This is all the information, all the data, all the code, everything. And you have a person, Dr. Date, who has a profile and it's related to this research object, and you can see this identifier that kind of is giving this attestation, a stamp, a peer review to this research object. And as a result, what you can see is you start building up this map of research that is very highly contextual, very highly persistent, and traversable. So then we get into the big problem is, well, we're not putting our data up there in the first place, so have you solved it? And this is where you get into some of the more app-level work that DeSci Labs is doing. So we have this underlying protocol. The underlying protocol is super important for making sure that we are actually tracing the research. But then we're working on making a really pretty, calm, gentle interface where you can publish all your work. It's just a very simple user flow. You throw up your manuscript, your data, your code, you upload whatever you want. Your authors, a lot of your metadata is automatically extracted, so it's easy, a quick check. You can claim any badges, reviews that you want someone to do. You kind of click a button, you say, hey, I need someone to review my open code. I need someone to review my data. I need someone to review this thing. And then it can send out, eventually, a bounty, not yet, to do that, and then you have a research object. You can publish it anywhere, and you have a whole complete package. We also have SciWeave. This is an AI research assistant, also built on top of this really highly contextual research graph. So it looks, right now, it's in chat interface, right? You're chatting with research, but we have this additional filtering layer of, have you had high quality attestations? Are you actually research that has been validated and verified? Do you have your code? Do you have your data? And so it will allow you to eventually set your own filters. I think right now we're starting with minimum viable product, which is we have research that can come in and we're querying it. But the goal is to take that context that we have in order to make sure that the data being fed in can be adjusted by the user and can be shifted. And then we have a referee finder. This is another really big pain point of academic journals and especially of a lot of like diamond open access journals where everything is working on volunteer labor and things like this. The cost of finding a reviewer is very high. You have a massive spreadsheet of people to look into. Most of them are not responding, increasingly so, because everyone's stressed and unfunded and everything's bad. But the academic referee finder, what it does is it understands the manuscript, kind of gathers it. It generates an understanding of what are the other papers in this space, and then says, here are the 10, 12 expert reviewers that you might want to reach out to. It automatically checks, are you co-authors? Are you gonna have a conflict of interest with this particular review? And all you gotta do is just drag and drop your your publication in, so that all the information goes in and you can automatically have a good idea of who should be reviewing your paper. So that's kind of the overview, my short overview of just metadata, why it's important, why the underlying protocol is important, and what we can build once we actually have a contextual and functional research graph. So thank you guys so much. And then, yeah, maybe one question as the next speaker comes up.